Okay, so this is the 2024 Ordinary Level Deferred Maths Paper 1. Question 1a, Fia has €1,500 saved. She put this money in a savings account with a rate of 3% per annum compound interest. Find how much money will be in the account after 1 year. So we have a formula for this. The final value is equal to the principal times 1 plus I to the power of t. So the final value of this amount is going to be the principal, which is €1,500, that's P, 1 plus the interest rate is 3%. So we want to put that in as a decimal into our formula. So that's 0.03. You just divide that by 100. So you got to raise that to the power of t is equal to 1. When you do that, you can just put that into your calculator and you get €1,545. That's it for part 1. Okay, so let's have a look at part 2. Hence or otherwise find how much money will be in the account at the end of 2 years. So you can use the same formula again. F is equal to P times 1 plus I to the power of t. So the original amount again was €1,500, so we put 1,500 there. The interest rate again was 0.03 or 3%. This time we're leaving it in for 2 years. So when you do that, you get €1,591.35. Okay, let's look at the next question, part B. The standard rates and thresholds of the USC in Ireland for 2024 are given in the table below. So the first €12,012 that you will earn, you will pay 0.5% in USC. The next €13,748 that you earn, you'll pay 2% of that. And the next €44,284, you're going to pay 4% of that amount. And then the balance will be at some top rate that we're not given there. So at what annual income does a worker start paying the top rate of USC? Well, all we've got to do is add these three numbers here. So you take 12,012 plus 13,748 plus 44,284. That'll give us a total value of 70,044, €70,044. So you need to earn this amount here before you reach the top rate of USC. And that's it for part 1. Okay, let's have a look at part 2. Mike's annual income for 2024 is €65,000. Work out how much he will pay in USC in 2024. Okay, so we've got to use this table then to work that out. We know he earns €12,012, so we have to get 0.5% of €12,012. So let's write that out. So we need to get 0.5% of €12,012. We'll work that out in a minute. We know that he earns €12,012. He also earns €13,748 more than that. So let's get 2% of that. So we want 2% of 13,748, and then we need to get 4% of whatever's left over. So let's work that out. So we want to get 4% of the balance. So we know that he earns €65,000. So we've got to subtract these two amounts to see how much more than these two amounts he actually earns. So when you add these two together, you get 27,560. So really we just got to subtract that from what he earns to work out how much we're going to get 4% of. So let's do that. When you subtract those two, you get €39,240. So that's what we're going to get the 4% of, 39240. So you get each of those. This will be €60.60. This one here is 274.96. This one here, 4% of 39,240 is 1569.60. All you've got to do is add those three, and that's the total amount of USC that Mike has to pay. So when you add those three together, you get €1904.62. That's how much USC that Mike has to pay. Okay, so this is question 2. In this question, I squared is minus 1, z1 is minus 4 plus 2i, z2 is 2 minus I. They're two complex numbers. Plot and label z1 and z2 on the Argand diagram below. Okay, so z1 is minus 4 plus 2i. So you need to come out the x-axis, or the real axis in this case, to minus 4. And then go up the y-axis, or in this case the imaginary axis, 2 units, so that's 2i. So our z1 will be there, so I'll just mark that z1. z2 is 2 minus I, so you go out the real axis 2 units and then down the imaginary axis 1 unit, and you'll end up here. That's z2. So that's part A1 done. Okay, so let's look at part 2. It says write down the value of z1 bar, where z1 bar is the complex conjugate of z1. So z1 was minus 4 plus 2i. So the complex conjugate of that is minus 4 minus 2i. You just change the sign in the middle there. So part 3 says work out the modulus of z1. That is find the modulus of z1. Give your answer in the form a root b. So we have z1 is minus 4 plus 2i. We want the modulus of z1, which just means that you've got to get the square root of a squared, which is minus 4, so it's minus 4 squared, plus b squared, which is plus 2, so that's 2 squared. So if you get the square of minus 4, you get plus 16. Minus 4 times minus 4 is plus 16. You get the square of plus 2, you get plus 4. That'll give us the square root of 20. Now the square root of 20, if you type that into your calculator, you'll get 2 root 5. Okay, let's look at part B. U is equal to a plus 4i and v is equal to a plus bi. There are two complex numbers where a and b are integers. Given that u minus 2v is equal to minus 3 plus 10i, find the value of a and the value of b. So we know that u minus 2v is equal to minus 3 plus 10i. So I'm going to put u in here and v in here. So u is 1 plus 4i. And then we've got to subtract twice v. Well, v is a plus bi. And we know that's equal to minus 3 plus 10i. So I'm going to multiply out the left-hand side. And we will get, let's see, 1 plus 4i minus 2a and then minus 2bi. That's equal to minus 3 plus 10i. Now I'm going to take the real parts and put them together. The real parts are the parts without the i's attached. So it's 1 minus 2a, that's the real part. And then we have plus 4i minus 2bi is equal to minus 3 plus 10i. Now what I'm going to do with the I parts, with the imaginary parts here, is just factorize out the I. So I've got 1 minus 2a here. I've got plus in brackets 4 minus 2b. And all I've done is factorized out the I here. So on the right hand side I've still got minus 3 plus 10i. Now when you have a complex number equal to a complex number, the two real parts are equal and the two imaginary parts are equal. In other words, we can say 1 minus 2a must be equal to minus 3. And we can also say 4 minus 2b is equal to plus 10. So the real part is equal to the real part and the imaginary part is equal to the imaginary part here. So if you take the minus 2a here, and that's going to be equal to subtract 1 from both sides, you get minus 4. That will give me a is equal to minus 4 divided by minus 2 is 2. So a is just 2. Over here we have minus 2b is equal to, now I'm going to subtract that 4 from both sides. That'll leave me with 6 on this side. Divide by minus 2 will give me a b as minus 3. So a is equal to 2 and b is equal to minus 3. Okay, so let's have a look at question 3. Solve the following inequality in x, which is natural. 5 times x minus 3 plus 2 is less than 11. List your solutions and remember that the solutions are going to be natural numbers. So let's do that then. We have 5x minus 3. So we've got 5x minus 3 plus 2 is less than 11. So first thing we're going to do is multiply out the brackets. So we've got 5x minus 15 plus 2 less than 11. 5x minus 15 plus 2, go down 15, go up 2. That'll leave you at minus 13 is less than 11. Going to add 13 to both sides. So that'll leave me with 5x, and if I add 13 here, I'll get 0. So that will mean I'll have to add 13 to this side. So that'll leave me with 24. Next thing I've got to do is divide by 5, because the 5 is multiplied by the x. So that gives me x is less than, and now I need to divide the 24 by 5, so it's 24 over 5. So 24 over 5 is 4 and 4/5. So we've got to write our solutions in here. Now remember, it says that x is a natural number and our solutions are less than 4 and 4/5. So the first natural number less than 4 and 4/5 is 4. The next one is 3. The next one is 2. The next one is 1. So there are our solutions, 1, 2, 3 and 4. Okay, let's have a look at B. Write the following expression as a single fraction where x is not equal to 0. That's because we have x on the bottom of the first fraction, so you can't divide by 0. And x also cannot be equal to minus 1, because if minus 1 was x, underneath the second fraction there we'd end up with minus 1 plus 1, which is 0. Again, you can't divide by 0. X is real. Give your answer in its simplest form. So we'll start with 1 over x minus 2 over x plus 1. First thing we're going to do is write down our lowest common multiple. So that's going to be these two denominators multiplied. So in other words, x multiplied by x plus 1. So what you've got to do next then is look at this first fraction here. Look at the denominator x and say, what did I do to that x to give me x times x plus 1? Well, I multiplied by x plus 1. So you must multiply the top of the fraction by x plus 1 as well. Right in the minus, and then look at x plus 1 here. What did we do to x plus 1 to turn it into x times x plus 1? Well, we multiplied by x, so multiply the top of the fraction by x. So this is our answer. However, it says give your answer in its simplest form, so we would be expected to simplify this. So we end up with 1 times x is x, 1 times 1 is 1, minus 2x over x times x plus 1. That's equal to, well, x minus 2x is minus x. So we end up on the top with 1 minus x. On the bottom we've got x times x plus 1. And that's it for part B. Let's look at part C. Use algebra to solve these simultaneous equations. Okay, well the first equation is xy is equal to 6. The second one is x minus y is equal to 1. If we take the first equation, what I'm going to do is write x in terms of y. So x is multiplied by y on the left hand side, so I'm going to divide the left hand side by y to leave me with x. Divide the right hand side by y as well, so x is equal to 6y. I'm going to substitute that in for x in the second equation. So instead of x here, I'm going to write in 6 over y. Minus y is equal to 1. I have a y on the bottom of the fraction, so what I'm going to do is multiply each term in this equation by y. Multiply 6 over y by y, it'll leave me with 6. The y's will cancel. Multiply y by y, it'll leave me with y squared. Multiply 1 by y, that'll leave me with y. So what I'm going to do now is bring everything over to the right hand side. So I'm going to subtract 6 and I'm going to add y squared. So if I add y squared, it'll leave me with 0. And if I add y squared to the right hand side, I'll end up with y squared plus y squared. Subtract 6 from the left hand side, I'll end up with 0. And subtract 6 from the right hand side, I'll end up with minus 6. And I also have this plus y there as well. So what I've got to do now is just simply solve this quadratic equation. So I've got y times y. And remember, I've got 6 here. 6 is 1 times 6, or it can be 2 times 3. I want to combine 1 and 6 or 2 and 3 to give me a 1, a plus 1y in the middle. So the only way I can do that is with a 2 and a 3. I'm going to put the 3 there and the 2 there. I need to multiply the 3 by the 2 to give me a minus 6, so the two signs have to be different. I'm going to say this is plus and this is minus. So this should work, okay? Y times y will give me y squared. 3 times minus 2 will give me minus 6. And the one in the middle then, multiply 3 by y, that's plus 3y. Y times minus 2, that's minus 2y. So plus 3y minus 2y does give me plus y here. Okay, so let's just finish this off then. I'm going to say that y plus 3 must be equal to 0, or y minus 2 must be equal to 0. The only way you can multiply these two brackets here together and get 0 is if one of them is 0. At least one is 0 anyway. So y plus 3 is equal to 0, or y minus 2 is equal to 0. So if y plus 3 is equal to 0, subtract 3 from both sides. That leaves me with y is equal to minus 3. Add 2 to both sides on this one. So you've got y is equal to plus 2. So I've got two values for y. So what I'm going to do now is I'm going to use one of our original equations. Let's say this one here, x minus y equals 1. I'm going to use this one here. I'm going to put in my two values for y here to find the x value. So let's do that then. So it's x minus y equals 1. So let's say y is equal to minus 3 first of all. We'll do that one first. So that will give me x minus 3 is equal to 1, which is just x plus 3 is equal to 1. Subtract 3 from the left hand side. That gives me x, because we'll just get 0 plus 3 minus 3 is 0. Subtract 3 from the right hand side, we get minus 2. Let's say y is equal to 2. Let's do that one. Well, we have x minus 2 is equal to 1. Add 2 to both sides because we have a minus 2 here. So add 2 to the left hand side, you get x minus 2 plus 2, which is 0. Add 2 to the right hand side, you get 3. So my answers are when y is minus 3, x is minus 2. When y is 2, x is 3. And that's it for question 3. Okay, this is question 4. F of x is the following function in x is real. F of x is equal to x plus 3 squared plus 5. Find the value of f of 0. So to do this, all we've got to do is substitute in 0 for x. So we want f of 0. So that's equal to 0 plus 3 squared plus 5. That's just 3 squared plus 5, which is 9 plus 5, which is 14. Part 2. Write f of x in the form ax squared plus bx plus c. So our f of x was x plus 3 squared plus 5. So you just got to square out this bracket. So that's just x plus 3 times x plus 3 plus 5. So that's, if you like, x times x plus 3 plus 3 times x plus 3 plus 5. In other words, you've got to multiply this x here by both of these and this 3 here by both of these here. So let's multiply that out. You get x squared plus 3x plus 3x plus 9 plus 5. And finally, that will give us, let's see, we have x squared anyway. We've got 3x plus 3x, which is 6x. And we've got 9 plus 5, which is 14. Let's look at part B. Solve the following equation in x. 3x squared minus 4x minus 9 is equal to 0. Give your answer correct to 2 decimal places. Okay, so when they say give your answer to 2 decimal places, you're not going to be able to do this by factorizing. What you're going to have to do is use the quadratic formula. So the quadratic formula is just minus b plus or minus the square root of b squared minus 4ac all over 2a. Now in our case, a is equal to 3, b is equal to minus 4, and c is equal to minus 9. So you just got to substitute these in. So minus b is going to be minus minus 4, which is plus 4, plus or minus the square root of b squared, so b is minus 4, which we got the square, minus 4 times a, which is 3, and c, which is minus 9. All of that is over 2a, which is 3. So let's see, we've got 4 plus or minus the square root of something over 6, 2, 3, 6. So minus 4 squared is 16 plus 16. Minus squared is plus, 4 squared is 16. Now here we've got minus times plus times minus. Well, minus times plus is minus, and then minus times this minus is plus. We've then got 4 times 3 times 9, which is 108. After that then we've got 4 plus or minus the square root of 124 over 6. So that means x is equal to 4 plus the square root of 124 over 6, or x is equal to 4 minus the square root of 124 over 6. Now 4 plus the square root of 124 over 6 is equal to 2.5225, 2.5225, and so on. And then you've got 4 minus the square root of 124 over 6. That's equal to minus 1.18925, and so on. It goes on forever. So we've got to round these to 2 decimal places. So the first one here, I'm kind of running out of room here, but the first one is going to be x is equal to, you've got to stop here, so it's going to be 2.52. The number after the 2 is also a 2, so we're going to leave the 2 as it is. So it's going to be approximately equal to 2.52. And the other one then, x is equal to, we've got to stop here. The number after the 8 is a 9. It's a 5, 6, 7, 8, or 9. It's a 9 actually. So we've got to round that 8 up to 9. So it's minus 1.19. And that's it. There are 2 answers for part B. Okay, let's look at part C. The graph of the quadratic equation g of x is shown on the diagram below, drawn to scale. The y-axis is not shown. Using the information below, draw the y-axis into the diagram. So they give us some information to do that. They tell us that the roots are x is equal to minus 2 and 3. So this must be minus 2 here, and this must be 3. If this was minus 2, that would be minus 1, 0, 1, 2, 3. So minus 2, minus 1, 0. 0 would be here. So you'd imagine the y-axis would be here. So let's draw that in. Now you guys would need to use a ruler. I've got to do this freehand. So you would draw the y-axis down along here like this. Again, make sure you use a ruler. Now they give us another bit of information in this question. So they tell us here that g of 0 is equal to minus 6. In other words, when x is 0, y is minus 6. So that would just mean that when x is 0 here, the y value on the curve would be minus 6. So this number down here would be minus 6 on the y-axis. So I'm just going to put that in as well. So this would be minus 6. So this is 0, minus 6. This would be minus 2, 0. And this would be 3, 0. I think that's probably all we had to do. Using the information below, draw the y-axis into the diagram, which we've done. The roots are that and that. G of 0 is equal to minus 6. Label the y-axis and the points where g of x cuts both the x-axis and the y-axis. So it says to label them. So I'm going to put in some more labels here. So this would be minus 1, minus 2, minus 3, minus 4, minus 5, and this is minus 6. This would be minus 1, this would be 1 and 2. So this would be 1, 2, 3, 4, 5, 6. Okay, and I think that's about it. That's all we had to do. And that's it for this question. So this is question 5A1. In Cueva's gas bill, the volume of gas used is converted to kilowatt hours. The current reading on Cueva's gas meter is 12,518 cubic meters. The previous reading on Cueva's gas meter was 12,398 cubic meters. The conversion rate is 1 cubic meter is equal to 11.5452 kilowatt hours. Find the volume of gas used since the previous reading in meters cubed, and hence show this is equal to 1,385.424 kilowatt hours. Okay, so the first thing we've got to do is find the volume of gas used since the previous reading. That's just a simple subtraction problem here. So we've got to take 12,518. We've got to subtract 12,398. When you do that, you get 120 cubic meters. So that's the first part of the problem solved. So that's the volume of gas used since the previous reading. Now the next thing we got to do is show that this is equal to 1385.424 kilowatt hours. Well, each cubic meter is 11.5452 kilowatt hours, so all we've got to do is take 120, multiply it by 11.5452. When you do that, you do indeed get 1385.424, and that's kilowatt hours. Okay, so that's part 1. Let's have a look at part 2. Gas costs 13.46 cents per kilowatt hour. Find the cost of the gas used by Quiva during this period. Give your answer in euro, correct to 2 decimal places. Well, we know that she used 1385.424 kilowatt hours. So if it costs 13.46 cents per kilowatt hour, all we've got to do is multiply those two numbers. So we're going to take 1385.424 kilowatt hours, that's how much she used. We're going to multiply that by 13.46 cents. When you do that, you get 18647.80704, and that's in cents. They say give your answer in euros, so we've got to change that to euros. So there are 100 cents in a euro, so we've got to divide by 100. So it's 186.4. Now we've got to stop here. We've got to take the decimal point and bring it back to here. So 7 is our last number. The number after 7 is an 8, so we've got to round that up to 8. So it's 146.48 euros. Okay, let's look at part 3. Quiva's total gas bill is 227.47 euros before VAT. Work out Quiva's total gas bill after VAT at 9% has been added. Give your answer in euro, correct to 2 decimal places. So there's a few ways of doing this, but the easiest way is probably just to get 9% of 227.47 and then just add it on. So 9% is 9 over 100 or 0.09. So whichever way you want to do it, you can multiply by 0.09, you can multiply by 9 over 100, 227.47. When you do that, you get 20 euros, 0.4723. So then all you've got to do is just add that on. So you've got 227.47 plus 20.4723. We've got to give our answer correct to 2 decimal places. So when you do that, you get 247.94 to 2 decimal places. And that's part 3. Okay, so this is part B. Quiva wants to estimate the area of her farm in meters squared. She measures at intervals of 200 meters starting at the right hand side of the farm. These measurements are given on the diagram correct to the nearest meter. So the question is, use the trapezoidal rule and the measurements in the diagram above to work out an estimate for the area of the farm in square meters. So you got to use the trapezoidal rule and these measurements here. So the trapezoidal rule is just, the area is going to be h over 2. H is each of these widths here, from here to here, from here to here, from here to here, from here to here, and so on. It's all the same, it's all 200 meters. These widths here are all 200 meters. So it's going to be 200 meters over 2, and then it's going to be multiplied by the first height here, if you like, is 0. So we're going to start from here, so this height here is 0. So it's going to be 0 plus the last height, which is this height here, 440 meters. So we'll add 440. And then it's going to be plus twice what you get when you add up all the other heights. So it's going to be twice 430 plus 510 plus 450 plus 360. You don't put in the 440 again, we've already used that one. So really that's it, that's your calculation, that's your numbers substituted into the formula. So all we've got to do is work that out. So 200 divided by 2 is 100. You've got to multiply that by what you get when you do all of this. So it's 0 plus 440, so that's just 440 plus twice what you get when you add all of these, and that's 1750. Okay, so when you do that, then you get 100 times 440 plus twice 1750, that's 2 zeros 0, 2 5s 10, put down 0, 7's 14, 1 is 15, put down the 5, 1's 2, 1 is 3. Okay, so when you do that, then you just add these two here and multiply by 100, you get 394,000 cubic meters. And that's it for this question. Okay, so this is question 6a. H of x is the following function in x is real. H of x is equal to x cubed minus 6x squared plus 7x plus 6. So we've got to find h prime of x. H prime of x is the derivative of h of x. So we're going to write down h prime of x is equal to, let's look at the x cubed first. You take the 3, bring it down in front of the x, write down the x and reduce that 3 to 2. We're going to take a look at the minus 6x squared. So what you've got to do is bring the 2 down, multiply it by the 6. That becomes 12. Write down the x, reduce the power by 1. Take the 7x to the power of 1 here. I've written in the 1 up here. Bring the 1 down, multiply it by the 7. That becomes 7. You can write in the x if you like at this stage, but if you reduce the power by 1, it becomes 0. And with the 6, it's a constant. If you differentiate a constant, you just get 0. So we'll just end up with a 0 out here. So just to simplify that, we've got 3x squared minus 12x plus 7. X to the power of 0. Anything to the power of 0 is just 1. So 1 times 7 is 7. So this is our answer here. 3x squared minus 12x plus 7. It says then, hence find the slope of the tangent when x is equal to 1. So when you find a derivative of a function, it's really the slope function. It gives you the slope of any tangent at any x value. So we have our x value, x is equal to 1. So our slope, in this case, is going to be 3, put the 1 in there instead of x squared, minus 12, put the 1 in there instead of x, plus 7. So that's our slope of the tangent at the point x is equal to 1. So let's just do that. We have 1 squared, which is 1 times 3 is 3, minus 12 plus 7, and that will just give you minus 2. So the slope of our tangent at x is equal to 1 is minus 2. Okay, let's look at the next part. The graph of the function h of x is shown on the coordinate diagram below for x is greater than or equal to minus 0.5, less than or equal to 4.5. Draw the tangent to the graph of h of x at the point where x is equal to 1 on the diagram above. Use the same axis and scales. So what we know about our tangent is that the slope is equal to minus 2. That means that the line will slant in that direction. That's a negative slope. If it was in that direction, we would get a positive slope. So we want the tangent to be at this point here at x is equal to 1. Now, if we draw a line, let's say through this point, this one, this one, and this one, what you'll end up with is a straight line. Now I have to do this freehand. You guys doing this would need to use a ruler. So if you draw a line like this, hitting the curve at this point here, what you'll find is that the slope of that line is minus 2. The reason for that is that if you drop a triangle, let's say down along here like this, and along here, or you could even do a bigger triangle if you wanted to, the distance up along here is 2 units. You're going from 6 to 8, so that's 2 units. If you look along the horizontal direction, you're going from 1 to 2, so that's 1 unit. So if you do the rise over run method, so the slope, if you like, is just rise over run, we would get 2 over 1, which is 2. But because it's sloping in this direction here, or slanting in that direction, it's going to be minus 2, which is what we got in the previous part of this question. So that line has a slope of minus 2. That's our answer to that part of the question. Let's look at the next part. The first 3 diagrams below show the graphs of the function a, b, and c. These functions are cubic, quadratic, and linear, respectively. So let's see. The next 3 diagrams below show the graphs of the functions d, e, and f. Each one of these is the slope function, the derivative of either a, b, or c. Write d, e, and f in the correct place in the table to match each function to its slope function. So we just look at a first. So a is a cubic function, and when you differentiate a cubic function, you get a quadratic function. The only quadratic function there is this function here, e. This is a parabola here, so this is our quadratic function. So a is going to have a slope function e. Let's look at the next one then. B is a quadratic function. When you differentiate a quadratic function, you get a linear function. So if we look at our functions here, we have two linear functions. We've got a horizontal one here, and we have this one here. Now, if we have a look at our function here, if we look at it from here to here, the slopes of all the tangents are going to be negative. If you draw any tangent along here, it's going to slope in this direction. It's going to slope this way, so it's going to be negative. So from this x value here all the way down to this x value here, the slopes are going to be negative. And you can see with this slope function here, we're looking at negative y values all the way up to this x value here, which would correspond to this vertex of this parabola here. After that, all the tangents will slope in this direction, so they'll have positive slopes all the way up along here. And we can see from this x value here, which is this value here, we have positive y values up along here. So this, in other words, this quadratic function here, when you differentiate it, will give this function here. This will be its slope function. So b will be f, and then c then is this function here. You can see that the slope is the same. The slope is constant all the way along here. The slope doesn't change. It's a linear function. So if you look at d here, this y value is the same all the way along here. So this y value here is the slope of our linear function. So this will be d. And that's it for that question. Okay, let's have a look at question 7. Lillian and Dara visit a 50-meter swimming pool. Lillian swims 50 meters at a constant speed. She stops for a rest after the first 50 meters and then swims a distance of 50 meters at a different constant speed. The graph labeled L shows the distance that Lillian swims for the first 110 seconds of her swim. So this is the graph here. Now I've drawn a red line here as well. We can ignore that at this stage. That's the answer to a later question. So we're just looking at L here, Lillian swim. This is it here in black. So we have time on the x-axis in seconds, and we have distance on the y-axis in meters. So she swims 50 meters out to here, and that takes 40 seconds. She then takes a 10-second rest and then swims the remaining 50 meters, and that takes from 50 seconds to 110 seconds, so that's 60 seconds. So that's our graph that we're going to look at now. How long does Lillian stop for? Well, we can see here in black that she stops from 40 seconds to 50 seconds, so that's just simply 10 seconds. Let's look at the second question. Find Lillian's speed for the first 50 meters. Give your answer in meters per second. Well, we know that speed is distance over time. You may be familiar with Dad's silly triangle. So we've got D here, we've got S here, and T here. Multiply these two. So speed is distance over time. Distance is speed times time, and time is distance over speed. So we want Lillian's speed, so it's distance over time. So all we've got to do is put in the distance. The distance is 50 meters, and the time it takes is 40 seconds. Find Lillian's speed for the first 50 meters. So if we look at the first 50 meters here, it takes her 40 seconds down here. So you got to put 40 on the bottom, and that just simplifies to 1 1/4 or 1.25 meters per second. So let's look at part 3. Does Lillian's speed increase, decrease, or stay the same in the second 50 meters? Give a reason for your answer. So let's look at her distance and time for the second 50 meters. So if we look at the graph here, we can see that for the second 50 meters, it takes her from here which is 50 seconds, to 110 seconds. So that's 60 seconds. So she does the second 50 meters in 60 seconds. So let's work out her speed. So her speed is, again, distance over time. So in this case, the distance is 50 meters and the time is, this time is 60 seconds. So when you maybe reduce that to a decimal, you get 0.83 with the 3 repeating. So it's 0.83333 and so on. So her speed is 0.83 meters per second. Now her speed in the first 50 meters we worked out as 1.25 meters per second. So she's actually slowed down. So her speed decreases, and the reason is 0.83 repeated is less than 1.25 meters per second. Okay, so that's part A finished. Okay, so let's look at part B. Dara swims at a constant speed of 10 meters every 7 seconds. How many seconds does it take Dara to swim 50 meters? Okay, so if we take Dara, then he swims 10 meters and it takes 7 seconds. Well, if he does 50 meters, that's 5 times more in distance. That would be 5 times 7, which is 35 seconds. Okay, let's look at part 2. Dara starts swimming 10 seconds after Liliana. He swims 50 meters, stops for 5 seconds, and then swims a second 50 meters at the same constant speed as in part B1. Graph the distance Dara swims on the diagram on the previous page and label it D. Use the same axis and scales. So that was the red line that I had drawn on the graph. So let's start then. Dara starts swimming 10 seconds after Liliana. So we're going to start here, 10 seconds after Liliana starts. The second part then just states that he swims 50 meters, stops for 5 seconds, and then swims a second 50 meters at the same constant speed as in part B1. So in part B1, he swims 50 meters in 35 seconds. So the first 50 meters he swims in 35 seconds. So if we take here, this is where he starts. We've got to go 10, 20, 30 and 5. So out to 45 seconds here, that's where he does the first 50 meters. He then stops for 5 seconds. So 5 seconds is just from here to here. So from 45 to 50 seconds. And then it says he continues on and does the second 50 meters from here to here at the same speed again. So it should take the second 50 meters, 35 seconds. So if we look at that, we've got 50, 60, 70, 80, and out to 85 seconds. So at 85 seconds, which is here, that's where he finishes the swim. He's completed his 100 meters. So that's it for part 2B. Okay, let's look at the next part. So this is part C. The average speed for the world record of the women's 100 meters freestyle is 1.934 meters per second. Work out how long it took her to swim the 100 meters in seconds. Give your answer correct at 2 decimal places. So in this case, we're looking for time. If you use Dad's silly triangle, you'll see that its time is distance over speed. In our case, we have a distance of 100 meters. And the speed was 1.934 meters per second, 1.934. So when you do that on your calculator, you get 51.70630.817, and that's seconds. So we have to round this to 2 decimal places. So 2 decimal places is here. So we can see we have a 0 here, but the number after the 0 is a 5, 6, 7, 8, or 9. So we've got to round that 0 up to 1. So it's 51.71 seconds. Okay, let's move on to part D. The formula for finding the cost of heating a swimming pool to a certain temperature is given by the equation C is equal to 1.163 P times V times T2 minus T1. P is the cost of electricity per kilowatt hour. V is the volume of water in the swimming pool in cubic meters. T1 is the average air temperature in degrees Celsius, and T2 is the pool temperature in degrees Celsius when heated. Mike has a swimming pool with a volume of 9 cubic meters and wants to heat it to 25 degrees C. The cost of electricity is 0.431 euros per kilowatt hour. Work out the cost of heating the swimming pool when the average air temperature is 13 degrees C. Give your answer in euros, correct to 2 decimal places. Okay, so let's just write down our formula first anyway. So we have C is equal to 1.163 P times V times T2 minus T1. This is just a case of sticking in the numbers and working it out. So on the right hand side we've got 1.163 and we've got to multiply that by P. P is the cost of electricity per kilowatt hour, and that's 0.431. We've got to multiply that by V. V is the volume of water in the swimming pool in meters cubed, so that's 9. And then we've got T2, which is the pool temperature in degrees Celsius when heated. He wants to heat it to 25 degrees, so we're going to write in 25 there. We've got to subtract T1, which is the average air temperature in degrees Celsius, and that is 13. And that's really it. It's just all calculator work after that. So when you do that on your calculator, you should get 54.135324. And then we've got to round this to 2 decimal places. So it's going to be 54. 2 decimal places stops here. We can see we have a 3. After the 3 we've got a 5, 6, 7, 8 or 9. So we've got to round that 3 up to 4. And that is the cost in euros. Okay, so let's move on to part 3. Work out the average air temperature T1 when the cost of heating Mike's swimming pool to 25 degrees C is 21.2 euros. Give your answer in degrees Celsius, correct to 1 decimal place. So this is really the same thing again. You write the formula down, you put in the numbers that you have, and the one thing you don't have is what they're actually looking for. So the formula is C is equal to 1.163 P times V T2 minus T1. So we have the cost this time. We know that it's 21.20 euros. 1.163. We've got to multiply that by P, which is 0.431. We've got to multiply that by the volume, which is 9. And then we've got 25 degrees C is what he wants to heat it up to. And we've got to work out the average air temperature, which is T1. So we have an equation here. We have everything in the equation except for one thing, and that's T1. So we can isolate that. So let's start simplifying this. We've got 21.20 on the left hand side. All I'm going to do here is multiply these three things here. What I get when I do that is 4.511277. That's multiplied by 25 minus T1. Okay, the next thing I'm going to do is I'm going to divide both sides by this here because it's multiplied by the bracket here. So if you divide 21.2 by 4.511277, you get on the left hand side 4.699334579, and that's equal to 25 minus T1. Okay, so the next thing I'm going to do here is subtract 25 from both sides to get rid of this here on the right hand side. So I've got to do this here minus 25. If I do that, I'll get minus 20.30066542, and that's equal to minus T1. So what you do is multiply both sides by minus 1, so you'll get T1 on the right hand side, and you get 20.30066542 on the left hand side. Now we want to round this to 1 decimal place. So 1 decimal place is here, so we're going to stop at the 3. The number after the 3 is a 0, 1, 2, 3 or 4, so you leave the 3 as 3. So our answer here is just 20.3, and this is the temperature, the room temperature, which is in degrees. And that's it for this question. Okay, so let's have a look at question 8. A firework is set off from a harbour. The height of the firework above sea level can be modelled by the function h of t, which is equal to minus 4.8 t squared plus 41.65 t plus 20, where h of t is the height of the firework above sea level in meters and t is the time in seconds from when the firework is set off. T is always going to be positive, t is real, and the height h of t is always positive as well. Show that the firework is set off from a height of 20 meters above sea level. So when the firework is set off, time is 0. So really what they're asking us to find here is h of 0. So in other words, put in minus 4.8, put in 0 for the time. So when you do that, this here will become 0, this will become 0, and you're just left with 20, and height in this case is in meters. So that's part A1 done. Let's look at part 2. Complete the table below to show the values of h of t for the given values of t. Give each value of h of t correct to the nearest whole number. So I filled that out already. I did one here just to show you what you need to do. So for example, I did this one here. So I have time in seconds as 4. So I put 4 in here, 4 in here, 4 in here. That's just calculator work after that, and you get 109.8. It says give each value of h of t correct to the nearest whole number. So that means you would finish here. The number after the 9 is a 5, 6, 7, 8, or 9, so you've got to round that up to 10. So it's 110, and this is in meters. So you do exactly the same for each of the other ones. 3 of them are already done for you, but that's what you would need to do. The next part of this question asks us to draw the graph of h of t on the axis below for time between and including 0 and 8. So again, I've already done that. So if you look at the table, you've got 0, time, height is 20. So at 0, we've got a height of 20. At 1, we've got a height of 57. So I put a point in here. At 2, we've got a height of 84. So that's here. At 3 seconds, we've got a height of 102, and so on. So you just join them up, and that's part 3 done. Let's look at part 4. The firework fails to explode. Continue your graph in part A3 on the previous page to find how long it takes from the time of set off for the firework to reach sea level. That is, find the value of t for which the height h of t is 0. Show your work on the graph and write your answer in the grid below. So what they want us to do here is just continue this graph down along here. It's a little bit shaky there, but I'm going to say around there, okay? So to me, that's about 9.1, 9.2 seconds. So that's when it would hit the water. So in other words, the harbour is here. This is the harbour. If you like, the firework is set off. It goes off in this direction, and it lands down in the water here after 9.1 seconds. So I'm going to put 9.1 seconds here. Okay, so let's look at the next section then. This is part B. The height above sea level of a second firework can be modeled by the function g of t, and that's quadratic. It's minus 5t squared plus 45t plus 20, where g of t is the height of the firework above sea level in meters, and t is the time in seconds from when the firework is set off. T is positive, t is real, and g of t is positive as well. The firework is designed to explode at its maximum height. Use calculus to find the value of t when the second firework is at its maximum height. So we start with our function. Our function is g of t, and it's minus 5t squared plus 45t plus 20. Now that's quadratic. When you graph it, you get this kind of a parabola here, and it's upside down because your leading coefficient is minus. It's minus 5t squared, so it's going to be an upside down u if you like. So we want to find the maximum height, this point here. So what you got to remember is the tangent at that point will look like this. It's horizontal. So this will have a slope. This will have a slope of 0. So how do we find that? Well, if you differentiate a function g of t, so we put g prime t here, you'll get 2 times minus 5 is minus 10, t to the power of 1 plus 45. So you bring the 1 down, multiply it by the 45, reduce the power by 1. So it's t to the power of 0, which is 1. So this here will give us this is our slope. This is our slope function. So we can find the slope of any tangent at any time t. We need the slope to be 0. We want to find this t value here. So let's just let minus 10t plus 45 equal to 0. That'll give us minus 10t is equal to minus 45. And then finally that'll give us a time then. Divide by minus 10. You get 45 divided by 10 minus divided by minus is plus. So you get 4.5 seconds. So after 4.5 seconds, the firework has reached its maximum height. Okay, so let's have a look at the next part. Use your answer to part B1 to find the maximum height of the second firework. We know that it takes 4.5 seconds, but what's the actual height? So what you do is you write down the original function, which is g of t is equal to minus 5t squared plus 45t plus 20. We want the time to be 4.5 seconds. So really we're looking for g of 4.5. This will give us our maximum height. So minus 5 times 4.5, which we've got to square, plus 45 times 4.5 plus 20. So when you do that, you get 121.25 meters. So after 4.5 seconds, it reaches its maximum height, and that maximum height is 121.25 meters. Okay, so let's look at part C. A pyrotechnician uses a type of gunpowder when making fireworks. The gunpowder mixture is made up of 3/4 potassium nitrate, 3/20 charcoal, and 1/10 sulfur. Express the ratio of potassium nitrate, charcoal, and sulfur in the ratio ABC in its simplest form, where A, B, and C are natural numbers. So in other words, we want to get rid of these fractions. So let's start. We have 3 over 4 is to 3 over 20 is to 1 over 10. That's potassium nitrate to charcoal to sulfur. So let's just see what we can do with these three numbers. What I'm going to do first is just convert them to decimals. If I convert 3/4 to decimals, I get 0.75. 3/20 is 0.15 and 1/10 is 0.10. What I can do now is just multiply each of these by 100. That'll get rid of the decimal. It'll bring the decimal point 2 places to the right. So I get 75 is to 15 is to 10. Now what I notice is I can divide each of these by 5. So if I divide 75 by 5, I'll get 15. Divide 15 by 5, I'll get 3. Divide 10 by 5, I'll get 2. So that's my ratio changed from fraction format to whole number format in its simplest form. Let's look at the last part then. There are 25 grams of charcoal in the gunpowder mixture. Work out how many grams of potassium nitrate there are in the mixture. So we know that we have potassium nitrate, and that is 15. And then we've got carbon, and that is to 3. And we've also got sulfur, which is to 2. We've just worked that out. This is sulfur. So 15 is to 3 is to 2. If you add those three, you get 15, 16, 17, 18, 19, 20. So there are 15 20ths of potassium nitrate in a mixture, 3 20ths of carbon in a mixture, and 2 20ths of sulfur in a mixture. We know that 25 grams of charcoal is in a particular mixture. So in other words, 3 20ths is equivalent to 25 grams of charcoal. We want to find out how many grams of potassium nitrate there are. So we need 15 20ths. So what I'm going to do is go from 3 20ths to 1 20th. In other words, I'm going to divide this by 3. So divide 25 by 3. That's 25 thirds. And now I want to go up to 15 20ths for the potassium nitrate. So that's going to be equal to 25 over 3 times 15. And that's actually equal to 125 grams of charcoal. And that's it for this question. Okay, let's have a look at the next question. This is question 9. A company sells memory sticks. The memory stick costs €19.99. The cost was reduced to $16.99 in a sale. Find the percentage discount on the memory stick. Give your answer correct to the nearest percent. Okay, so it went from $19.99 16.99 down to 16.99. That's a difference of €3. So it was reduced by €3. We've got to find €3 as a percentage of the original cost, which was 19.99. So you put it over 19.99 and you multiply by 100. That gives you a percentage of 15.0075 and so on. We've got to do this to the nearest percent, so that's going to be approximately 15%. We're going to stop here. Okay, so that's part one. Let's have a look at part two. A company buys the memory sticks from the USA. They buy 10,000 memory sticks for $9.50 each. Use the exchange rate €1 is equal to $1.09 to work out the total cost of the memory sticks in euro. Give your answer in euro, correct to 2 decimal places. Okay, so we've got to look at our exchange rate first of all. €1 is equal to $1.09. Now, usually the way I like to do this is put what you're looking for on the right hand side. We're asked to find euros, so I'm going to reverse these two and I'm going to put 1.09 on the left hand side and I'm going to put the €1 on the right hand side. I'm going to work from there. Now, they buy 10,000 memory sticks and they're $9.50 each. So I'm going to take the $9.50, I'm going to multiply that by 10,000. That will give me a total cost of $95000. So we've got to convert $95,000 to euros. So we come back here to our exchange rate. We've got 1.09 is equal to €1. First thing I want to do is go down to $1. So divide by 1.09. So that's 1 over 1.09. And then I want to go from $1 up to $95,000. So what I got to do is multiply. So it's 1 over 1.09 multiplied by 95000. When you do that, you get corrected 2 decimal places. You're going to get 87155.96, and that's euros. Okay, let's look at part B. Sean boarded a flight in Shannon traveling to New York. The flight took off at 9:45 in the morning. New York's time zone is 5 hours behind Ireland's time zone. The total time of the flight from Shannon to New York is 7 hours 35 minutes. What is the local time when Sean's flight is due to land? Okay, so if we take the Irish time as 09:45, New York time then is going to be 5 hours behind that. So subtract 5 hours, you'll get 04:45. So that's the local time in New York when Sean boarded his flight, or when the flight took off at 9:45 local time in Ireland. It was 4:45 in the morning in New York. So what we got to now do is take our 04:45 hours and we've got to add 7 hours and 35 minutes. Well, if we add 7 hours to 4, that'll give us 11 hours. And then if we add 35 minutes to 45 minutes, that'll give us 80 minutes. Now there's 60 minutes in an hour, so that's really 12 hours and 20. So our time in New York then is 12:20. Okay, next question, part C. The table below shows units of computer storage and the number of bytes they're equal to. So 1 gigabyte is 2 to the power of 30, 1 terabyte is 2 to the power of 40, 1 petabyte is 2 to the power of 60 bytes. Write the number of bytes in 1 gigabyte in the form a by 10 to the power of n, where a is between 1 and 10 and n is an integer. In other words, in scientific notation, give the value of a correct to 3 significant figures. Okay, so we want 1 gigabyte. 1 gigabyte is 2 to the power of 30. 2 to the power of 30 is 10737411824. We want to convert that to scientific notation. So we've got to take the decimal point, which is here, and we've got to bring it back to here. We want to make a number between 1 and 10. So the only way you can do that is to take that decimal point and bring it back here after the 1. So we get 1.07. 1.073741824. So let me just write that out. It's 1.073741824, and we want to bring the decimal point back again, so we've got to multiply it by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. So that's our answer. However, we need 3 significant figures. So significant figures are going to start on the very left here. So we're going to start here at the 1. There's a 0 in the middle here, so that's okay, that's significant. And then we have 7 as well, that's significant. So there's our 3 significant figures. So what we want to do is round to 3 significant figures. So it's going to be 1.0. Look at the 7, the number after the 7 is a 3. So in other words, it's a 0, 1, 2, 3, or 4. So therefore you leave the 7 as it is by 10 to the power of 9. And that's our answer there. Okay, next question. A desktop computer has 1 terabyte of storage. A NASA supercomputer has 7.6 petabytes of storage. Work out how many desktop computers are needed to equal the storage of the NASA supercomputer. Give your answer correct to the nearest whole number. So we have 7.6 petabytes. So if we look back up here at our table, a petabyte is 2 to the power of 60. So NASA supercomputer is 7.6 of these petabytes, which is 2 to the power of 60. We've got to see how many terabytes go into that. So that's 2 to the power of 40. A terabyte is 2 to the power of 40. So this is what we've got to do. We've got to see how many terabytes divide into the 7.6 petabytes of storage that NASA have. So let's just do that. If you look at the 7.6 and look at this part here, that's 2 to the power of 60 divided by 2 to the power of 40. Our laws of indices say that we can subtract the powers. We have the same base, it's a base 2, so we just take the 60, subtract the 40. So that gives us 7.6 by 2 to the power of 20. Now you can just type that into your calculator and that will give you 7969177.6. We have to round this to the nearest whole number. So the nearest whole number then would be 7969117. Now we have to stop here. So the number after the 7 is a 5, 6, 7, 8, or 9. So we've got to round that 7 up to 8. So that's part 2 done. Okay, so let's look at part D. At the start of 2021, the total amount of data in the world was estimated to be approximately 64 zettabytes. The predicted growth up to the start of 2029 is modeled by the function d of t is equal to 64 times 1.19 to the power of t, where d of t is the amount of data in the world and t is the time in years since the start of 2021. T is between 0 and 8 and t is real. Use d of t to find the predicted amount of data in zettabytes in the world by the start of 2026. Give your answer correct to 1 decimal place. So we have our function. It's d of t is equal to 64 times 1.19 to the power of t. In our case then we know that t is 5 years. We have the start of 2021 and we want to go up to the start of 2026, so that is 5 years. So really what we need to do is do d of 5, which is 64 times 1.19 to the power of 5. Now if you put that into your calculator, you will get 152.7266342. We now have to round this to 1 decimal place. So that is 152. 1 decimal place is going to stop here. The number after the 7 is a 0, 1, 2, 3, or 4. So we leave the 7 as a 7. And that is it. That is the amount of data in zettabytes that we're predicting will be in the world at the start of 2026. Okay, part 2 I've done already here. It says, in which year will the predicted amount of data first reach 200 zettabytes? Show your work on the graph. So we're starting here at 200 zettabytes and we just draw a line across here until we hit the graph and then drop down here, and you can see here that we're in year 2027. So our answer here is just 2027. The last part then, use suitable values from the graph on the previous page to estimate the number of years it takes for the amount of data to double according to d of t. Show your work on the graph and give your answer correct to the nearest whole number. So I'm going to start with 2022. So let's do this in red. So if we start at 2022 and go across here, that is 75 zettabytes. So that's 75 zettabytes there. This is in 2022. If we look at 2026 and come up along here, we can see if we come along here, we reach 150, which is double 75. So the amount of data in the world has doubled from 2022 to 2026. So let's just write that out. So in 2022, there's approximately 75 zettabytes, and in 2026, there's approximately 150 zettabytes. So it's taken approximately 4 years. It says give your answer to the nearest whole number. That's it for this question. Okay, so let's move on to question 10. The first 3 patterns in a sequence are shown below. Each pattern contains grey tiles and white tiles. Part A then says to draw the 4th pattern in the sequence into the box below. So I've done that here. Part B, complete the table below to show the number of grey tiles, the number of white tiles, and the total number of tiles in the first 4 patterns. Again, I've done that here. Part C1, find the formula in terms of n for the number of grey tiles in pattern n of the sequence, where n is an element of n. So n is a natural number, in other words. If we look at the sequence of grey tiles, it goes from 3 to 4 to 5, 6, and so on. So the formula that we can use here is Tn is equal to A plus n minus 1 times d. Okay, so if we just put in A is the first term, which is 3, plus n minus 1 times d is the common difference, and we can see that we just add 1 to each term to get the next term, so it's just times 1. So this is going to be 3 plus 1 times n is n, 1 times minus 1 is 1, and that just gives us our formula Tn is equal to 3 minus 1 is 2 plus n. So this is our formula that will give us the number of grey tiles in pattern n. Using this formula from part C1 or otherwise work out the number of grey tiles in the 25th pattern. So all we've got to do, write down our formula, Tn is equal to 2 plus n. We want T, term number 25. So that's just 2 plus 25. And that gives us 27. And this is grey tiles. Okay, next one. Find the total number of grey tiles in the first 25 patterns of the sequence. So really what we've got to do here is do the sum of the first 25 patterns. So our formula is n over 2 times 2a plus n minus 1 times d. So we want the sum of the first 25 patterns, so it's S25, so that's 25 over 2, n is 25, twice the first term. So in our case, the first term is 3 plus n is 25 minus 1 times d, the common difference we said was 1. So 25 over 2 is 12.5 multiplied by 236 plus 25 minus 1 is 24 times 1, which is 24. So 6 plus 24 is 30, and 30 times 12.5 is 375 tiles. So in the first 25 patterns of the sequence, there are 375 tiles. Okay, find how many white tiles are in the 8th pattern in the sequence. So let's look at the white tiles. So we go back to our table again. We have white tiles here, so we got 2, 6, 12, 20. So let's have a look at that. We have 2, 6, 12, 20. So if we look at the first difference, so we'll do it this way. So the first difference here is plus 4. We're adding 4. Here we're adding 6. And then here we're adding 8. So it's not a linear pattern. So let's go again, see is it quadratic? So what do? We add 2 here. And from 6 up to 8, we also add 2. So this is a quadratic pattern. So we have the first 4 terms here, we need to go up as far as the 8th pattern. So let's work from the bottom. So let's say plus 2 here, which means this would be plus 10, which means this would be 30. So let's go again. So we're adding 2 to 10, which will give us plus 12. So we got to add 12 to 30, so that's 42. Let's go again, add another 2 to 12, that's plus 14. So add 14 to 42, that's 56. And I think one more then, so let's add another 2 down here to 14, that's plus 16. Add 16 to 56, that's 72. So the answer here is the 8th pattern contains 72 tiles. Okay, let's look at the next one. Part D. The total number of tiles in pattern N for the sequence is Tn. The value of Tn can be found using this formula where B, C are elements of OR are constants. Tn is equal to n squared plus Bn plus C. Now T2 is equal to 10. Term number 2 is equal to 10. Use substitution in this formula for Tn to show that 2b plus c equals 6. So our formula is Tn is equal to n squared plus Bn plus c. We're told that T2 is 10. So if we put 10 here, then the n is 2. So it's going to be 2 squared plus b times 2 plus c. That'll give us 10 is equal to 2 squared is 4. 2b is just 2b plus c. And then finally we can subtract 4 from each side. That'll give us 6 is equal to 2b plus c. So that's it really. Let's look at the next one, part 2. Solve the following simultaneous equations to find the value of b and the value of c. So our equations are b plus c is equal to 4. And we have 2b plus c is equal to 6. This is equation 1, this is equation 2. I'm going to take equation 1 and I'm going to multiply it by minus 1. Because what I want to do is change this plus c here to a minus c so that it'll cancel with this one here. So we'll multiply equation 1 by minus 1. That'll give me minus b minus c, and then I'll have minus 4 here. I'm going to add equations 1 and 2. So if I add these two here, I'll get 2b minus b is just b. And then here I've got plus c minus c, that'll give me 0. They just cancel. And then over here I've got 6 minus 4, which is 2. So b is equal to 2. Let's work out c then. So I'm going to take equation 1. b plus c is equal to 4. This is equation 1. I'm going to substitute in 2 here for b. We just worked that out. So subtract 2 from both sides. That'll give me c is equal to 2. So our answers are, it just says find the value of b and the value of c. So b is equal to 2 and c is equal to 2. Okay, and that's it for this question and this paper.